Siddhineni Taranya, a final year student from Sheshadrirav Gudlavalleru Engineering College. I am presenting this work I did during my internship at Emertxe under the guidance of Mrs. Jayalakshmi N. Danyal. About this internship, the internship focused on IoT based home automation system, an emerging technology that connects home devices to the internet so they can be monitored and controlled remotely. This project integrates Arduino, Blink IoT Cloud, and sensors, actuators to automate home applications like lights, and fans. This internship gave me a real time exposure to IoT, Internet of Things, and embedded systems. Initially, we learned programming concepts in C and C, which are essential for embedded coding. Then we studied embedded system design, how microcontrollers, sensors, and actuators work together. Finally, we implemented on a IoT based project where we controlled electrical devices using a smartphone via the Blink app. The tools used were Arduino IDE for coding, Pixim Lab Simulator for virtual circuit testing, and Blink Cloud for IoT communication. In Taiwan, we discussed about C language, data types, modifiers, number systems, data representation. C language was developed by Dennis Ritchie in 1972 at Bell Laboratories. It is a general purpose, high level, and procedural language and the base for many modern languages in present days. Number systems. There are four types of number systems: binary number system, octal number system, decimal number system, and hexadecimal number system. In binary number system only there is two numbers 0 and 1. In number systems we can only represent with zeros and ones. Data types, there are primarily int, float, and characters. There are derived data types, arrays and pointers, and user-defined data types, enums and structures. We can represent data in bits, bytes, and memory storages of numbers. 1 byte is equal to 8 bits. That we can store the bytes of data in memory. Modifiers, there are short, long, signed, and unsigned. In day 2, we learn sign modifiers, decision making statements, looping structures. We learned about sign modifiers and decision making statements. Example, controlling LED states using if condition. Looping structures for while and do while loops help in repeating tasks like blinking an LED continuously. In day 3, we learned about operators and jumping statements, arrays. Operators are arithmetic operators, relational operators, logical operators, bitwise operators. For example, bitwise operators are often used in embedded systems to control specific bits of a port. In jumping statements like break and continue are useful in controlling program flow within loops. Arrays are yellow, storing multiple data values such as sensor readings in continuous memory locations. This enhances our ability to write efficient structured code for hardware control. In day 4, We learned about functions and pointers. Functions Functions make code modular and reusable. Example: writing a separate function to display data on LCD. We learn call by value, call by value, and call by reference, crucial for understanding how microcontrollers handle data in memory. Pointers were introduced variables that store memory address. Pointers are essential for direct hardware access and memory management in embedded systems. In day 5, we learn advanced pointers. Again, learned about Indianness, how bytes are stored in memory. Little versus big Indian. This is useful when transferring data between systems with different architectures. Practiced passing arrays of functions, an important concept for reading multiple sensor values. Written arrays using static memory to prevent loss of data after function execution. In day 6, we learn pointer types, strings in C, memory segments. Pointer types: null pointer, while pointer, and constant pointers with examples. In strings, we using character arrays and string handling functions. String copy, string length of the string, how to copy the string. We can use input output using gets and puts in strings. Memory locations, memory segments in embedded systems, code segment, stack, heap, and data segments to know where variables and instructions are stored. In day 7, we discuss about storage classes and preprocessor directives. Storage classes, we use auto, register, static, extern, register. Auto for local variables. Static, we use auto for local variables. Static for variables retaining values. We use extern for global sharing. Register for faster access. We use preprocessor directives like hashtag define and hash include, simply code and manage macros. Example: defining pin numbers for sensor using macros. In day 8, we learned about introduction to C++. Introduction. C++ was developed by Bajrani and Strop. C++ is a multi-paradigm language combining procedure and object-oriented features. POP versus OOP. Procedure-oriented programming and object-oriented programming. In POP, function-centric, less secure data handling. And OOP, object-centric with data encapsulation and abstraction. C versus C++. As key differences in approach, data handling, and structures. In object-oriented programming, class, objects, constructors, and access specifiers. Compared to C, it is a procedure. C++ is a object-oriented. C is a procedure-oriented. C++ is a object-oriented. OOP promotes data security and code rescue, which is important for scalable projects. For large projects, we can use C++. Access specifies public, private, and protected. It can be used in C++ language. Constructors special functions per object initialization, default, parameterized, and copy construction. We are used these all in C++. We now we going to concepts, destructors, pillars for object oriented programming. Like this is all in the C++ language. Destructor automatically called when an object is destroyed to release resources. For pillars of OOPs, encapsulation, abstraction, inheritance, polymorphism. Encapsulation is used for hiding internal details. We can hide internal details of the programming. Abstraction, a concept of the internal details, not a programming. We can hide concept, okay, programming concept of the data using, we can hide the data by using encapsulation. Abstraction, displaying or showing only essential field. Outside part of the only essential, you cannot show all the passwords for out. You can only show some type of data only. Inheritance. Inheritance is reusing existing code. Already we have some code that can reused by using inheritance. There are so many levels of inheritance: single, multiple, multi-level, hierarchical, and hybrid types. In polymorphism, we can functions behaving differently based on inputs, representing objects in multiple forms. Compile time, runtime, we can compile in some function overloading, and runtime in virtual functions. This is the basic concept we learn about C and C++. Now we go into the internship or for day 1. We identify project requirements, like we see something smart home, smart automation. Define project goals like controlling lights and fans using IoT. Collected hardware components, like not hardware components, we can use only simulation like Arduino Piximlab. Introduction to IoT concept device. In day 2, we can introduce introduction to IoT. Introduction to IoT devices communicating over the internet. In day 3, studied embedded systems, the backbone of IoT devices, comparing microcontrollers and microprocessors. Arduino architecture overview. In day 4, LED interfacing, we wrote a program using digital write to blink LEDs. In day 5, we discuss about CLCD LCD interfacing, learning how to send commands and data to a 6x2 display. In day 6, we interfaced temperature sensor, introduction to LM35 or DHT11. We can measure with DHT11. We can use DHT11 sensor for measuring humidity and temperature. Using analog read, we can read the data from something closed area. We can read some data. For this, we can use analog read. Before you are saying the in a day 3, in day 4 we use digital write. In digital write, from you can reading and taking the data values, you can taking from the LED. For that we can using digital write. In day 6, temperature reading, we can use analog read function. There are two different functions for reading, for calling, and for taking values and giving commands to them. Giving input, we can use analog read. Okay, that is the thing. In day 7, learn about PWM, pulse width modulation, a method to control voltage digitally useful for adjusting motor speed or LED brightness. In project timeline, we can in okay sorry okay and we completed that you in September 29 and to October 6. We have less classes. We can learn about something small using serial communication, serial dot begin, serial dot print, water level sensor integration, displaying level data over serial monitor. We can write the code for a serial tank. We can uh, observe the serial water tank inlet and outlet wall. We can discuss in that week. In October 7, we we discuss about the Blink app integration. Overview of the Blink app: install Blink app, create projects, get authentication token, code integration with IoT, Arduino IDE, controlling devices via mobile. This is all about the Blink app integration. Totally covered concepts are fundamentals of C and its applications, number system, data types, conditional statements, operators, arrays, pointers, functions, storage classes, various macros, header files, and C++. You can use, we can learn C++ also. In C++, encapsulation, inheritance, polymorphism, we can use. That all we can learn in that. Internet of Things. Internet of Things is in we can connect the data through the internet for other device. IoT concepts: physical devices like sensors, actuators to the internet for remote access and automation. There are so many applications and examples for this. For the examples for this IoT: smart homes for application control, smart agriculture for irrigation management, healthcare for patient monitoring, industrial IoT for predictive maintenance, smart cities for managing traffic and energy. The IoT ecosystem includes sensors, cloud connectivity, data processing, and user interface. And this is about the IoT. We can go into the embedded systems. Embedded systems are dedicated computer systems that perform a specific function within a device. Examples include ATMs, washing machines, smartwatches, routers, etc. It has some components about hardware and software. We can use hardware components like microcontrollers like Arduino, memory, sensors, actuators, input and output device. We can use software like firmware, RTOS, operating systems like RTOS. Applications of the IoT embedded systems: automotive like engine control, medical for pacemakers, industrial for automation, and consumer electronics. In this project, Arduino acted as the heart of the embedded systems, controlling all operations. This is about the embedded systems. Going to the Arduino IDE, there are versions. I can use Arduino Uno for this. The Arduino integrates developing an environment. This is the concept. There is two functions, void setup and void loop. In loop, we can iterate the statement. You can in void setup only you can serial dot begin you can use, and that's all about the Arduino. It is about the Pixim lab. In file, you can load X file. like board, you can select Arduino Uno board. In modules we have spare, we have in modules we have LEDs, motors again, as well as coolers, LEDs, Wi-Fi, Bluetooth module. In tools we have serial monitor, that I think this is a PIC lab. We can connect with the Arduino, Arduino IDE code. Okay, that's it. Topics covered related to IoT. You can cover the introduction to IoT, IoT architecture and its applications, embedded systems, Arduino IDE and PIC simulator, working LED and LDR, basic programming of controlling LED using LDR, about CLCD for displaying the commands, basic programming related to temperature control, Blink IoT applications, Blink IoT application apps, serial remote monitor, final project implementation. This is the block diagram for connecting IoT. Like we can write Arduino code, we can connect with the Pixim lab, then Blink app we can control with the mobile app. This is the overall representation of the project. According to this block diagram, Blink IoT app, you can Arduino, from Arduino, you can give the commands temperature, heater, cooler. Through this, it can read the through we can monitor in the Blink app. It's all for this. This is the Blink IoT mobile app. There is two tabs, for one tab for controlling heater and cooler, one tab for controlling inlet and outlet wall. First one is controlling heater and cooler. This is the on cooler switch, it is the heater switch. This is a gauge, can representing in the like range, and this is for the heater and this is for the inlet and outlet for serial tank. Inlet wall, this is outlet wall switch, this is the gauge for water volume. We can note these notifications in this. Okay, now we can go to the project. Now we can go to the project. We can start with this. Okay, something. Okay, this is like this. Okay, you can write the code in home automation blink control.info. This is for, I can already record this is okay. Definition, we can define all things like no authentication ID. This is only in the Blink app. Okay, now we can write about this is all SPI ethernet.h blink simple ethernet. We can all define this, we can all use this. This is for cooler pin. You can write commands like cooler on, cooler off. It in which display you can use this 7,0. This is for heater pin. This is for inlet for both are same. Yeah, you can use only pin LED screens. This is for inlet wall. Okay. After this is for outlet wall. You can use this. For this we can write inlet outlet and cooler on or off. In this setup we can use for temperature and water. For gauge we can write this code. Okay. This is for temperature, heater and cooler working. This is for that. Pins and you can use above the 37 degrees. So you can automatically off the heater, turn on the heater. Okay, after 35 degrees you can turn on the heater. Okay, this is for inlet and outlet wall. Water volume less than 2000, it okay. over the 2000 okay, turn off the outlet the cereal tank. You can use it for this. After cereal volume, we can brief. In void setup, there is a loop function. Not what a void setup. While loop, we can write the loop functions. Here we are only clearing the writing the LCD cursors. We set cursors for the serial tank, serial monitor, temperature, all these. Now we go to the LDR.cpp. For this LDR we can mainly we can include Arduino.h. This is only for signed values and unsigned values, that's all. For this in LDR.cpp we are LDR.h. There are also like we can implement with the only for the, there are a separate we can discuss about like this LED serial tanks. In serial tank inlet there is a main function. In main function we can give on for 0, 1 off for 0. There is a switches so we can give in no, that's a v1 v0. Okay, that's all in the main.h. In serial tank we give commands like inlet and outlet wall. This inlet and outlet enable and disable the pins. We can all write in the serial.cpp. In serial.h we can defining only pins. Temperature.cpp you can read the temperature and giving to the blink app. Pixim lab you can control with these all things. Temperature.system also .h we can also use for this only defining. Heater pin is 5, cooler pin is this can be connected with the Pixim lab. Only .h we can defining. This is all about the writing the code. We can export .binary and then you can check this without errors. Yes, it can be executed successfully. Then open the Pixim lab, load X file, load X file, board you can select now. Okay, build in desktop we have saving, build. Okay, it's can running it is successfully. Now opening toolbar Pixim labs tool. It's showing temperature 22.34 Celsius. Volume is 3000. The serial tank volume is 3000 and temperature is 27.4. This is LDR sensor. This is LED. This is the Ethernet port. This is the cooler. We can automatically on when heater switch is off. And this is all about these components in the Pixim lab simulator. Okay, this is the cooler pin. It's all. Now we can open the IoT blink app. Through the blink app we can monitor all these things while controlling the switches. Like you can off the heater pin. Now cooler pin is on. When heater pin is on, the readings was going continuously, moving that thing. When heater pin is on, the readings were note down continuously. It should be main thing. This is the tab 2 inlet and outlet wall. We can measure the serial tank. This is the serial tank. We can connect with the two comms. For this we can install serial port. We can connect with the COM1 and COM2. Okay, this is the serial tank. We can off the serial tank. We can also on the serial tank. We can represent like this. Okay, it is running. Okay, Okay, you can go to the serial. Okay, you can go to the temperature. When heater is on, the readings were continuously running, and here the notification should be displayed. This is the thing, and LCD we have to read the values. Okay, this is when cooler is on, the cooler is rotating. Okay, then heater will automatically off. This is the thing. And in tab 2 there is two switches we are discussed. When outlet valve and inlet valve, when outlet valve is on, it automatically decrease the water level. It can be observed in the serial cereal tank. This is for when inlet valve is on, we can automatically increase the volume of the cereal tank. This is the condition. It can and we can also notify this on the I can also see the notifications for this also, cereal tank and inlet and outlet valve. Okay, increasing when on this, it will increasing the cereal tank. This is the condition. Okay, can also display in the LCD itself. We can notify that also. You can see that notifications are there for this. Okay, this is for the project demo. You can display that. This all about the project demo. We can conclude this with this project demo. We can conclude this internship project. This internship The internship provided deep insights into programming, embedded systems, and IoT. I gained technical knowledge and practical experience through simulations and real hardware interfacing. The project strengthened problem solving and teamwork skills. Overall, it built a strong foundation for developing future IoT based innovations. Thank you. Thank you for giving this a opportunity and good internship.